it should be 1, 2, 3, 4. Now I will put here, then this. Yes. Now this, it is now 4th division. I have put 0.5 this per division. So it is 4, it is 2 volt. So this my signal here. So now it is calibrated one. Okay. Now it is calibrated one. Let me take out. What is the signal one? This one my signal one. I will put here. Okay. So yes, now it is, you see, I kept it at 1, 1, 1, no 2, 2. It is kept at it is at 8 volt. Okay, it is at 8 volt. I have kept at 2, so it should be for exactly 4. You see now 1, 2, 3, 4. Okay, so now you see this how important it is. If I don't take, if this function generator is very good function generator. So whatever reading it is giving, so exactly I should get it. Okay. So but when I saw that, I saw that no, when it is 5, then it is showing 4.5, when it is 8, then it is showing 7.5. So that means either this one is having problem or the calibration is having problem, but I know this one is correct. So I have to check the calibration one. Okay. So for known voltage and this, I think it is 1 kilohertz, this signal, this is 1 kilohertz. Okay. You can frequency as well as the time period, frequency as well as the time period corresponding time period corresponding frequency you can find out, you can calibrate as well as you can calibrate the voltage. That means you can calibrate the X scale and you can calibrate the Y scale. X scale is for voltage, sorry, Y scale is for voltage and X scale is for time. Okay. So here it is telling the frequency is 5 kilohertz. Okay. So if frequency is 5 kilohertz, now this is for Y axis, you know, for channel 1 and channel 2, and this is for X axis for both channel 1 and channel 2. So here time per division is given in millisecond. Okay. So now it is, we have put at I have put for this signal, say it is at where is black one? Oh, here it is. So black line is here. So I have kept it at millisecond, 0.2 millisecond or 0.1. So that one has to be careful. It is the 1 millisecond, but it is the 1 millisecond is okay. If I keep that as 1 millisecond, then I think it will be slightly difficult to X shift, slightly difficult. So I should 0.5, yes, 0.5. Okay. So each division is 0.5 millisecond. Okay, 0.5 millisecond. So now let me see the division for just check it. I will keep, okay. So I will measure this to this, you know, this to this. So this will be one wave, this peak and then down and then up and then going down. So this will be 1. So from peak this down. So if I start from, so one period I have to find out, So this, okay. So this to this, it is a 1 division, you see, it is 1 division, exactly 1 division. Okay. Here time period T, capital T, it is 1 division. and one division here scale I have put at 0.5 millisecond. 0.5 millisecond means 0.5 millisecond means time period 0.5 millisecond, then one division into 0.5 is the 0.5 millisecond. So, so 1 by t is the frequency, 1 by t is the frequency. So, 1 by t t is 0.5, t is 0.5, then 1 by t will be, it is in millisecond, that means it will be kilohertz. Okay. So, it is becoming 2 kilohertz, it is becoming 2 kilohertz, but here it is showing it is 5 kilohertz. So, that means that it is also not calibrated, this frequency part also not calibrated, or I am doing mistake, let me check it. Okay. So, here now I have put at 0.2, I have put at 0.2, yes. So, 0.2 millisecond per division. So, how many divisions are there? For one wave, these, okay. So, now I am getting 2, it's I am getting 2, more or less 2. Why? So, you have to take in middle for calculating time period, that is very important. Yes. So, I think you have to take in middle, otherwise there will be mistake. Okay. I have taken in middle. So, now this to this, or here 0.5 here there. So, I can see these two division, or this to this 2 division, slightly, yeah, more or less 2 division, slightly less than 2 division, since it is point, it is less than 2 division. So, it is a 0.2. So, it is I think 2.5 should be 2.5, then it could be 0.5 millisecond. So, I think it is not also calibrated. So, I have to do calibration, this one also, this time one also I have to do calibration. You see, this is the calibration knob. If you change this, it's the calibration change. Okay. Now, in this position actually it should be calibrated, but somehow in this oscilloscope it is not calibrated, we need to change something. So, if that is correct 5 kilohertz. So, 5 kilohertz means 1 by 5, that should be 0.2, that should 1 by 5 means 1 by 5 means 0.2. Okay. So, each division, not each division, this time period has to be 0.2. So, here time period, so when it become 0.2, I have kept this at 0.2 millisecond. So, it should be one division only. So, wavelength should be one division. So, nu is 1 by t. So, t equal to 1 by nu. So, 1 by 5 kilohertz means millisecond, it should come millisecond, 1 by 5 means 0.2 millisecond. So, I have kept at 0.2 millisecond here, but only I am confused whether this knob is 0.2 or yes, it is a 0.2. Okay. So, no. So, I think I have to do the calibration, okay, with known source. I think this is the source. So, let me do, and it is 1 kilohertz. So, one has to calibrate. So, I think, okay, one has to calibrate. Okay. So, from here I can see calibration, if I put this way, then how many division? So, starting this, so up to this, or this I think, starting from this to this. Okay. So, this one, let me exposition, let me put this here. Okay. One wave, one, this two. Okay. So, this is the full wave. So, from here down, so from here 1, 2, 3, 4, 5. So, slightly less than 5 I am seeing. So, I have to increase it. You see, I am able to change with 2. So, how much I am expecting? This is 0.5. So, I am expecting it should be 1. Okay, it is a 1 kilohertz, sorry, it is the 1 kilohertz, means 1 millisecond. If I put 1 millisecond, yes, if I 1 millisecond if I put, so 1 kilohertz, it will be 1 kilohertz if it is 1. Okay, so here to here. To if I put this as, so 1 division should be 1 millisecond, then it will be 1 kilohertz. Yeah, it's a more or less is fine, looks fine, looks fine. If I, it looks fine. Okay, so this is one, no, 1 from here, actually square. Let me just think over it. Okay, that means this, this, so 2. Okay, so it should be 1 2 1 2. So 1 2, so 2 division, 2 division. So, but it should be 1 division. So, if it is 1 kilohertz, it should be 1 division. Anyway, so I think it's looks, it's the 0.5 what I am saying. The knob has some shifted 1. So, if it is, I have kept it, I am thinking it is 1. If so, then here I am getting 2 division basically. I am getting 2 division means 2, oh okay, 2 millisecond, but it is 1 kilohertz. 2 millisecond, it is not giving 1 kilohertz, it is giving 500, 1 by 2, time period is t, 1 by t, 1 by 2 millisecond, 0.2, it is giving 0.2 kilohertz. So, I have to now, if it is for 1 millisecond, think for this other way I put 1, 2, 3, 4, 5, 6. Now if it is 6, so looks to me 2 division, and here it is 1 millisecond per division, time is 1 millisecond per another 2 millisecond, time period is 2 millisecond. If time period is 2 millisecond, it should be 5, 2 millisecond means 1 by 2 means 0.5 kilohertz, but here it is basically 1 kilohertz. So, but I do not know whether I am doing any mistake. So, actually this is one complete one, whether if I take if I take middle one, so this way it will go, instead of this will go and then it will come here. Yes, it is 2 anyway. So, one has to calibrate somehow. I think it may be okay. I think knob has some problem here. If I take 0.5, so here I am thinking it is at 1 millisecond, but this is not the case. It is at basically 0.5 millisecond. Okay, so I think this knob is not at the, yes, I think I was doing mistake for seeing this one, or this knob is not placed properly. So, it is basically whatever one it is showing, but it should be this 0.5. If 0.5, then it is 2 division, then it will be 1 millisecond. If 1 millisecond, then then it will be 1 by 1 millisecond, it will be 1 kilohertz. Okay. So, I think this knob, it is where I am seeing this is at 1 millisecond, it is not the case, it is at 0.5. So, one has to be careful, that is why this calibration is important. I think one should rectify this one. Anyway, so that way one can calibrate. Now, you put your signal, now that is the calibrated position. Okay. Now, in this case just you check it. I have put here, it looks to me 0.2, but it should be 0.5. Okay. If it is 0.5, then how many divisions are there? 1, this way. Okay. So, I have to keep at exact at middle, slightly up I will put. Okay. Okay. So, 1, 2 division. Okay. 2 division, each division is 0.1, but here it is showing 0.2, but it has to be 0.1. Okay. 0.1 millisecond into 2 division, then 0.2 millisecond. Okay. 1 by 0.2 is 5, 1 by 0.2 millisecond is 5 kilohertz, So, that is the case, 5 kilohertz. Okay. So, you see this is my old oscilloscope. We just, if unknown source is there here, you see intentionally I have taken this oscilloscope. This oscilloscope have some problem, calibration problem. To tell you the fact, it is not that just signal is coming and just we are seeing whatever, taking reading, it is not the case. you have to check properly. Okay. So, calibration is main part. So, for that it is given this this calibration signal, okay, this signal for calibration. So, how to do that? So, I was doing so, but that way also I was puzzled, because this function generator cannot give the wrong reading. So, it is correct, it is best function generator. So, but I was not getting that one, although, so I found that this knob is not at a, so it is displaced by 1, it is displaced by 1 more to this, towards this. So, when it is 0.2, then I have to, it has to be 0.5. Okay. So, I think this have some wrong things that one should rectify. Anyway, so thus we can measure the frequency of your signal and we can measure the voltage of your signal. Okay. So, then there are many others. So, these 3 knobs are very important: X shift, Y shift, as I told you. Now, I will here, you see there are a lot of other things, triggering are there. Okay. So, triggering level, you can see this triggering level anyway. So, here I think here it is best, no, okay, fine. So, now these are not working because this one is for I think for dual channel it can act, or let me just check it. Okay. Now, here you see there is a ground. So, if ground, so if that signal is grounded, if I put this grounded. Okay. So, this also you can check, you have signal and this grounded is a AC, now it is in AC and DC also, if you see, okay, press it, then it is in DC mode, it is in AC mode. Okay. So, if DC and AC, only DC, so you will see DC, or DC plus AC. So, you will see the shift of the when ground, it should be in middle, you know, it should be exactly, it is in middle. Okay. So, now to check it, if it is not middle, say if like this, so ground you can check, okay, this is not in middle. So, it should not be in middle, so it should be in, so you push it, okay, make it in middle. Okay. So, that way you can, ground can be used, then your signal, it is in middle. Okay. So, this middle position is very important when you are measuring the frequency, time period. Okay. So, similarly for other channel, if you there are second channel, okay, the same things are there, whatever here, if I put this signal in second channel. Okay. So, here it is not showing. So, what is the problem then? The signal I am not able to show, see there. What is the problem? Okay. So, this channel 2, but signal is not coming, although it is coming here. Okay. Okay, same signal in this channel it is coming, and this channel it is okay, DC AC. So, I have put a DC AC mode, AC signal. See, if I put here what some triggering, okay, it's need triggering. So, we have, it is not, so I am not able to catch this signal. So, we need to trigger it, external trigger, this calibration, okay. So, but where is that triggering function? I need triggering function store there, okay, no, external internal triggering, but what is the problem? I am not able to see his okay, keep it, okay, something one has to search, high frequency DC AC, line, low pass, okay. This is XY, I will tell you XY, where this TR having. But what is the channel 2? I have to select probably. Okay, triggering. I think this, yes, I got it. Okay. So, here there is option channel 1 or channel 2. So, it was in channel 1, okay, trigger 1 or 2. Okay. Now, trigger I is. So, there are many things, but I think this problem was this, it was in channel 1. So, I have to select channel 2. Okay. So, now I have select channel 2, then it is coming same one. You see here it is at point is a 2 volt. So, I have kept this 2 volt, okay, same signal you are getting, same. So, this also you can check, this is showing voltage and 1, 2, 3, 4, I think what is the, this is 8 volt, it should be 4, 1, 2, 3, 4, that we have to, this problem is here calibration knobs. Okay. So, I have taken this rough having problematic CRO, okay, having problematic CRO. So, here you see, so here so generally channel 1, channel 2 we calibrated once, then everything fine, it is not the case, you have to be careful. So, now here I am seeing it is 1, 2, 3, 3.5. So, I have kept this at 2, okay. So, it is basically 7 volt, okay, peak to peak amplitude 7, but it is showing here 8 volt, that cannot be the wrong. So, something wrong here. So, I need to calibrate this one also I check this calibration, but here calibration knob is broken, no, it is there, okay. So, red part is not there, but indicator is not there. So, it is not broken. So, calibration part I think I will take it, okay, keep it, okay, 1, 2, 3, 4, it is a 2 volt per division. So, it is 8. So, one can do the calibration using this one also. So, this channel 1 is completely independent from the channel 2. Okay. So, both channel has to be calibrated. So, since this signal is already calibrated from the reliable source, so that is why I use this one, not without using this one. Okay. So, this is now calibrated. Okay. So, this now my system again is a channel 1 and channel 2. Okay. Now, so when you want to know about a signal, so you switch on the oscilloscope, the intensity focus. Okay. After doing this, you will see the stress of the beam, and then you can shift along the x and y position of that beam. Now, x position x, and this is the time axis, and y position is the voltage axis. Okay. Both are has to be calibrated. So, calibration options are there that I told you. Okay. So, this one and this is another, okay, channel 2. So, now there are some application, you need to dual channel like Lysages, like if you want to measure the phase difference of two signals, if you want to measure the frequency relation of two signals. So, you need two input to the oscilloscope. So, then we tell one input, one will be for x input and another will be for y input. Okay. Both will be in voltage, then this both one, okay, because these two it will be independent of time. So, if I take this another signal, then we can compare these two signal. Okay. So, that time we have to use the channel 1 and channel 2. Here we have you see, I think channel 1, channel 2 dual mode. Okay. So, either you can use channel 1 or channel 2, or you can use both dual mode. Then I have to press this one. Okay. So, here you can see that one is having signal, and another one I have not given any signal. So, another one, you see here. So, this is the signal and this the I have not given any signal. So, you give similar another signal. Okay. So, then compare these two. So, we have to keep in dual mode. We can add this, so add mode is there. So, chopper, some triggering 1, 2. So, there are various mode function is there. So, okay. So, just preliminary few knobs, about few knobs I told you how to just check the signal, measure the frequency and then their voltage, how to calibrate the system. Okay. So, now I think I will stop and I will just continue for showing you the for comparing the two signal at a time in next class. Okay. So, thank you.